welcome back. Today's topic is the elimination of epsilon productions. As we know, last lecture we completed how to eliminate the useless variables. Okay, see, other name for epsilon production is also called as the null productions. Okay, see, before eliminating epsilon productions, let me tell you some theory behind this. For example, there is a context free language. CFL equals to strings is epsilon comma a comma 2a's comma 3a's and so on. Let's assume. Okay, now I'm asking you to write a grammar which generates this context free language. So how we can write a grammar for this language is CFG equals to s tends to AS slash epsilon. Then see, what's my important point is, if context free language contains epsilon, then there is a necessity to include epsilon is one of the production in the grammar. Okay, without using epsilon it's not at all possible to write the grammar. Okay, for example, let's take one more context free language. Let's say context free language is A only. Now I'm asking you to write what is the context free grammar that generates this language is s tends to ax, then x tends to epsilon. Now there is no epsilon, but I return including epsilon. Okay, in this case you can remove epsilon from this production. Okay, right? So my point is, if a context free language contains epsilon, then there is a mandatory to include epsilon production in its grammar. Okay, for example, in context free grammar it contains a epsilon production, then context free language not contains any epsilon as the word, then there is no necessity to include epsilon production in the context free grammar. Okay, let's see how to eliminate epsilon productions. Okay, so first define what is nullable variable. In a context free grammar, x is a nullable variable if and only if, for example, x has the production like epsilon. So we can say directly x is a nullable variable. In another way, how we can identify x is also a nullable variable means, for example, x derives some non-terminal and so on, it derives some non-terminal and so on, finally it derives epsilon. So based on this we can say x is also nullable variable. Okay, then before discussing how to eliminate epsilon production, let me write down what is the procedure. So procedure to eliminate epsilon productions. Yeah, the first step is identify nullable variable Vn. Then second step is, let's say I have a production like B tends to A. Let's assume A is the nullable variable. Then how we can remove A is replace A by epsilon and add all its possible RHS combinations, to the production. Then don't add again A tends to epsilon. This is the procedure. Okay, you can understand this procedure very well if you solve one problem. Let's take, this is the first example. The given grammar is s tends to ax slash bx, x tends to a slash b slash epsilon. So non-terminal is s and x, and terminal is small a small b. So now I'm asking you to remove epsilon production from the grammar. Okay, so first identify what are the, as for procedure, first I am asking you to identify what is the null variables. Okay, basically it is also variable, so how we can write it as v. So which variable it is? Null variable. So Vn, that is equals to, you see, by seeing this production x tends to epsilon, so straight away we can write x is the null variable. Is there any null variable? So not possible. If you replace x with epsilon, s derives a. If you replace x with epsilon, s derives b. So this is only null variable. Then remove the null production from the grammar is according to the procedure. The first step is identify the null variable, and second step is if there is a production of the form b tends to a, replace a with epsilon and add all possible combinations of the RHS. Don't add a tends to epsilon. Okay, let's now, what is x variable? I mean, what is the null variable? X only. Okay, so how we can write is s tends to a x slash, if I replace x with epsilon, then what is result? Only a only. That's what, x with epsilon, then result is a. Then what is next production? Bx. So bx. If I replace x with epsilon, then what is result? B only. So b. Similarly, x tends to a slash b, then x tends to epsilon, then don't add x tends to epsilon. That's what I told in procedure. So x tends to a slash b. This is the grammar after eliminating epsilon from this grammar. Let's try this with another example. This is the second example. Given grammar is s tends to a, b, a, c, a tends to b, c, b tends to b slash epsilon, then c tends to d slash epsilon, d tends to d. I'm asking you remove the epsilon production or remove the null production is the same. Okay, so as for procedure, first identify what is the null variable in the given grammar. So vn equals to, see, c tends to epsilon, so straight away it is the null variable, we can write it as, so c. Then next, b tends to epsilon, so b is also null variable. Then so through derivation also we can identify what are the null variables. If it is a tends to b, so what is b? Null variable. If I replace with epsilon, then c is also null variable. If I replace with epsilon, totally a derives what? Epsilon only. So consider a is also null variable. Then remove this null variable along with their productions from the grammar is, take the starting production, s tends to a, b, c, so first replace a with epsilon. If I replace a with epsilon, what is remaining? b, a, c only. So b, a, c. Then if I replace b with epsilon, what is result? A, c only. If I replace c with epsilon, what is result? A, b, a only. So I told you in procedure, add all possible RHS combinations. So if I replace a, b at a time with epsilon, a with epsilon, b with epsilon, what is result? A, c only. If I replace b and c with epsilon, what is result? A only. If I replace a with epsilon, c with epsilon at a time, result is ba only. If I replace a with epsilon, b with epsilon, c with epsilon, what is result? A only. Then take the next production. A tends to b, c. If I replace b with epsilon, result is c only. Then if I replace c with epsilon, result is b only. If I replace b with epsilon, c with epsilon, result is epsilon. So I told you, don't add epsilon production again. Okay. Then take the next production. B tends to small b only. We are not adding epsilon again. Then take the next production. C tends to d only. I am not asking you to add epsilon. Remove epsilon. Then what is the last one? D tends to d only. Okay. So if it is the grammar with epsilon production, this is the grammar without epsilon productions. Let's take one more example. S tends to as slash a tends to small a capital A slash epsilon. Okay. Now remove epsilon production or remove null production from the grammar. See, as for procedure, first identify what is the nullable variable Vn equals to. By seeing this, a tends to epsilon, straight away we can identify A is the null variable. Then S tends to A. If I replace A with epsilon, S is also nullable variable. This is one somewhat different problem than others. So yes. Then next. So remove the epsilon production. Take the first production. Yes. So S tends to A. Yes. Slash. If I replace S with epsilon, what is there only? A. So A. Then next production, S tends to capital A. If I replace A with epsilon, what is there? Epsilon. Okay. Now I am adding epsilon to the S production. I clearly mentioned in procedure, don't add epsilon to the production, but there is necessity to add because because this grammar derives epsilon as the symbol in its language. Okay, that's why it's mandatory to add epsilon to the starting production. This is one special case in epsilon productions. Okay, then next, A tends to small a, capital A. If I replace a with epsilon, what is there only? Small a only. This is small a. This is what about how to eliminate epsilon productions from the grammar. Okay, next lecture we can see how to eliminate unit productions from the grammar.